So first of all, download this surface model of steel bracket from our link given in video descriptions and open it in Solidworks. Then go to the simulation tab and start a new simulation study. You can give it a specific name and select static from general simulation type. OK. Our first step is to define the thickness of this surface body. You can see that here is a message that thickness is not defined. So we will treat this steel bracket surface model as a shell model. Just go to edit destinations. Here define the thickness, that is 10 millimeter, and treat it as a thin, and go to offset. Here is the, we will select this middle surface in order to assign the thickness about its mid plane. You can go to the shell manager. Here is the surface model. You can see that this is the 10 mm thickness, and the offset is the middle, where 5 millimeter from this surface above and 5 millimeter from the surface below. So we have defined a shell element using shell manager by assigning the thickness to a surface body. Now assign the material, that is alloy steel, and apply our fixtures. Go to the fixture and select fixed geometry. From here select these two holes and this one. So this model is fully fixed or constrained about these two holes. Now we will assign a load on this edge. So go to the loads and select the force. We will apply load in y directions, sorry, in x directions. We just select this edge and from here select the selected directions. We have to define a plane edge or face for directions. So just select this edge as a reference and units are SI. Select the force. You can see here force is being applied in the positive z directions. Just change the reverse the directions and apply a load of 500 Newton. You can increase the symbol size also to 150. So our next step is to define the curvature based mesh. So go to mesh and click on the create mesh. From mesh parameters, select the curvature based mesh and define the element size, that is 3 millimeter. Okay. So mesh is being generated now. Mesh has been created now. You can see here. This is a surface mesh. Now run the simulation study and wait until your solution converge. After that, we will evaluate stresses in this model as well as deformation and the factor of the safety. So you can see now our simulation has been completed. Here is the one measure stress values. You can check these values in megapascals. So go to edit definition and then select the units into megapascal. Here you can see that maximum stress is 62 megapascal that occurs here at the edge of this bracket, while the material yield strength is 620 megapascal. And the displacement is 0.13 that occurs at this portion. If we go to edit definitions, we can show the maximum displacement that occur at the top. We also superimpose the deformed shape with undeformed shape. You can see now this is the undeformed shape and this is the deformed shape with our definite scale. Just animate this deformation behavior. Now calculate the factor of safety using the one measures stress failure criteria. So minimum factor of safety is 9.4. So in this way today we learn how we can carry out shell model simulation with SolidWorks. Please make a practice of this lecture. Thank you for watching.